All right, this is now the last video of this chapter. This has been a very long chapter, so thanks for bearing with me. We are just going to look at just a little bit at the end, summing it up a little bit with some soap talk. So here we go. We have talked about, sometimes I think your book kind of overlaps a little bit here, but that's okay. It's good to kind of come back to some of these concepts in other chapters. We know that water is a polar molecule, so it will also interact, likes dissolve and likes dissolve, because it has similar intermolecular forces with other things that are polar, which is great if you have a water-soluble stain. But if you have something and you're trying to now get your clothes clean and you've spilled something that's non-polar, how are you going to get it out? Because it won't get washed away in the water. It won't interact with it. So you could use something that would be non-polar, because the non-polar would interact. That can be a little bit difficult, usually pretty volatile. A little bit more toxic, so they're used at dry cleaners. But one other thing you can try is using soap. Okay, when you're doing your laundry, you will add soap, detergent, and they pretty much have the same kind of structure. They're just made a little bit different, soap versus detergent. But here's the main thing: they have two parts of them. They have a very long carbon chain, okay, that we call the nonpolar tail. Okay, it looks kind of like the tail there. And then you have the other end, okay, which is a polar head. So this way, okay, your soap or detergent can interact now with something that's polar, like the water, okay, the solvent that it's in, and then whatever your dirt or oil or grease is, your stain, can interact with the nonpolar big tail. How does that form? Okay, what does that look like when you actually are doing your wash? You have the hydrophilic part, okay, that's the water-loving part. That's the polar part. That will kind of be interacting with the solvent, your water. You have the hydrophobic part, okay, that's a nonpolar tail. That's going to interact and kind of lift up and work out whatever stain you have. And the structure then that forms, okay, because the tail part will all surround the oil and interact with that, and then the polar head then allows it to interact with water, so it allows you to take that dirt from your laundry and then wash it away. The micelle is that structure that we were just talking about. Just kind of note what that cross section looks like. Okay, you can see all the polar heads on the outside and then the nonpolar on the inside, and you can see then, okay, that it makes that circular little structure there. So that's that. If you remember from a while back, we did do a demo with milk and food coloring. I don't know if you remember that, but the food coloring was polar, okay, more polar, water soluble. The milk was more hydrophobic, okay, so more nonpolar, and they wouldn't interact. When we dropped the food coloring into the milk, it kind of just stayed on its own. And then once we added soap, okay, soap had the polar head, the nonpolar tail. It was able to interact and allow the food coloring and then the milk to mix. It was a pretty cool demonstration. You can feel free to try that again on your own. All right, so that kind of brings that all back together. Here are all the things we've learned in this chapter. It did cover quite a bit, so make sure you go through. We talked a lot about energy and entropy and how the energies change as you dissolve something. We've talked about a lot of the calculations involved, define molarity, do calculations with molarity, and then we looked at colligative properties, vapor pressure, boiling point, freezing temperature, and then the last little bit was soap thrown in there. So enjoy your studying of chapter 12. We'll continue on in the next chapter.